going to be the first artifact review for Team 4 on row crop detection using computer vision and machine learning for steering of autonomous tractors. Team 4 members include Brandon, Huron, Leo, Siraj, and myself, Thomas. The topics we'll be covering today will be our sprint goal, some sample code that we derive from our research, our overall research on machine learning, computer vision, and TensorFlow. Later on in the video, we will be going over some working code that'll show row crop detection as well as detecting dogs. We are also going to show some working code on the Z camera. To get started, we'd like to explain that our sprint goal for Sprint 1 was to do as much research as we could regarding machine learning and all the facets that go along with it. Since machine learning is new to all of our members in our team, we really needed to get a base understanding of it and how it was going to help us in succeeding in creating a model to detect crop rows. Once we had a basic knowledge of machine learning, we wanted to start creating basic algorithms for crop row detection and set up the hardware that we'll be using during the project. So moving over to our Taiga board, as you can see, we're able to complete the tasks in full. Now moving over to our private GitHub repository, we've created multiple branches to go over with our user stories from our sprint board. Now, we are still in the process of creating more branches for each of the tasks in the user stories, but we haven't fully pushed them to GitHub as they are pending code review, and our sprint actually lasts until tomorrow, so we're just getting as much as we can up there. Now, we do have a lot of sample code that we've collected, which is helping us with our goal of creating our own crop row detection algorithm and model. So as you can see, we have done a lot of research on OpenCV, had up a lot of stuff here. Moving into the TensorFlow research, we have some TensorFlow object detection with the scripts here and the images that will be tested, for instance, some dogs and the people here. And then we have some TensorFlow models that we have. Now, these are all just scripts written in Python here. This is some of the sample code, as well as how to set up TensorFlow and Jupyter Notebooks, which is a tool that we'll be using for TensorFlow. We also have some more TensorFlow machine learning models. Here is some of just the tests that printed out here. And then we also have the Z camera working here with the script it's detecting here. And here's some of the, as you can see, some of the images. And then we also have the crop row algorithm, which we'll show later on in the video. As you can see, here's one of the scripts, as well as the image here. Now I'm going to go ahead and hand it over to another member of our team so he can go ahead and talk about all the research that has gone into learning about machine learning during the sprint. Thank you.
Majority of our research in Sprint 1 has been focused on getting up and running with OpenCV, practicing various TensorFlow models, looking at a lot of example projects in order for us to really understand how to utilize these things in our crop row detection project. So stuff like image recognition and object detection in OpenCV, sort of understanding the anatomy of how you go from an input image to, whatever you want to detect in the image. This sort of gives you a little bit, nice little outline in an example of a cat. We also have been researching into the neural network aspect of how to actually build a model in TensorFlow, and Keras seems to be one of the best APIs when it comes to working in Python and TensorFlow. Personally, I've worked with a couple of research projects with OpenCV, so I'm going to show you a little bit here. So this is an OpenCV project to detect like a smile, like a person like when you smile through your webcam. So this taught me a little bit of the OpenCV library and how you can use it to detect things and to actually, draw an actual image. So I'm gonna play this here and you can see what I mean. So in this example project, this is actually taking from a live feed from a webcam, and see, as you can see, the eyes are detected, and when you actually smile, it's also going to detect, and that's all done with Python and OpenCV. You can choose where to draw the rectangles or whatever else, but in this case it's squares and rectangles. So as you see, one sec. Yeah, when he's smiling, it actually detects puts the little rectangle around the smile. So that's been the bulk of my research.
Hi, my name is Kiran Gautam. As part of this project, I was doing some research on machine learning with TensorFlow and also doing some research on how to write algorithm using OpenCV to identify the image and mainly the crops. Let's dive right in. So here it's a sample code that I put together with my research to try to identify the crop rows. So here it's going to take a sample crop picture. So this is our sample picture, and it's going to go through different manipulation. For example, first it's going to go through a color change. It's going to change the picture to grayscale. Then it's going to manipulate the picture itself. It's going to put some threshold, and finally it's going to use a OpenCV library that is hook lines to actually try to detect the pattern and draw the line in there. Let's go run it real quick. Right now it's not working as working on the way that I would like, but it's just a basic concept and the basic framework how we can actually refactor this code and try to use this framework to identify the crops on the crop rows. The next thing I want to show you guys uh, about the machine learning framework that is TensorFlow. Let's check out my branch real quick. So the TensorFlow model. So this is a sample code that actually utilizes the existing machine learning model and try to find out what the image has. For example, in this case, this model that I'm using is from ResNet. That's existing model that's going to identify the dog type on the image. Let's run it right now. So it's running. It's basically trying to take these images, process it through the machine learning model from ResNet, and trying to show us what the dog name is. All right, cool. So as you can see here, I was playing with four of these. I was testing 4 of these images. So it successfully found out what the dog name is for all these 4 images. So this is just a basic framework or concept that we can utilize when you train our machine learning model and when you build our own machine learning model for crop row identification. With the machine learning framework like TensorFlow and also OpenCV framework, we can achieve the end goal of the project, and that is to identify the crop row through machine learning. Thank you.
This is Brandon, and for this sprint I was working on some basic stereo image capture and applying some transformations to that we can later use for our crop row detection. And let's see that run. And in these 2 windows we can see the left and the right images from the stereo camera. And then in this 3rd window we can see the disparity map. So that is calculated by looking at the differences between the 2 views, and we can later improve this and apply it to our crop row detection algorithm.
Hello everyone, my name is Suraj Kesi from Team 4 project number 6, row crop detection using computer vision and machine learning for steering of autonomous tractors. As a part of the project for the sprint 1, as a team we have research on various topics, open computer vision, machine learning using TensorFlow, convolutional neural network. I have research on convolutional neural network, which will be used to detect the row crop using the image recognition. And for this project, I have research on various on the convolutional neural network, which is also called CNN, and these are the lot of links to the videos, to the slides, to the articles over here. And for this project, we'll be using for this project for the convolutional neural network. We'll have multiple layers: input layer, hidden layer, output layer, and the hidden layer, it will have other layers inside it: convolution layer, pooling layer, which will help us detect the row crops for the project. And that will be for now.